Okay, so today we are picking up where we left off from yesterday, a little bit more complicated today. Today's lesson, I would say, is one of the more strange lessons I teach all year. At first glance, it's going to look really complicated. It's not. Okay, it is not a complicated lesson. It's just dealing with some things that you're not super familiar with, so it's going to be a little bit strange. So keep that in mind as we get going here. To start off, bell work shouldn't be too bad. We're converting negative 225 degrees to radians if I'm converting that thing. Abby, what'd you do to convert that? hmm Multiply by pi and divide by 180, because if we want to get in radians, we want pi with our answer. The degrees needs to cancel, and then we multiply through. What'd you end up getting there when you negative 5/4? Again, when we talk about radians, we always want to include it as a fraction. When we're in radians, it's negative 5/4 pi. Talk with your neighbor real quick. Which quadrant is negative 5/4 pi going to fall into? Talk with each other. Show me with your fingers. Which quadrant do you think negative 5/4 pi is going to fall into? Good. Negative 5/4 pi. Maybe the easier way to look at it is 225, because we can understand that better. If it's negative, which way am I going? Backwards. I'm going down. So this would be negative 90 degrees. That would be negative 180 degrees. This would be 270 degrees, so I don't want to go quite there. It would be in the middle. That's negative 225. Okay, just working our way through and make sure we understand it. Next one. We are converting 7 pi over 12 from radians to degrees. So, Kate, what'd you do there? 180 degrees over pi. She doesn't want pi in her degree answer. That's silly. But we do want degrees. So when you multiply that out, what'd you get? Yep, 105 degrees. Which quadrant is 105 degrees going to fall into? Yeah, that one's the second one. That one's pretty easy. 90 degrees plus a little bit more. 105 degrees. Questions there? Last one. An adjustable angle pop-up lawn sprinkler has been installed in an awkward corner of your neighbor's yard. This sprinkler, assuming full water pressure, can spray everything within 8 meters. Given that angle has been set to 70 degrees, how much lawn will the sprinkler head water? So you got a little sprinkler head. It goes like this. It sprays water out, and then it goes 70 degrees. It can turn 70 degrees. How far can it shoot? 8 meters, because that is the distance. And so it can spray everything in that sector. Okay, again, a sector is a fancy word for the whole circle. Okay, so imagine this was a whole circle. It can spray anything in this portion. So our goal is to figure out how many square feet can this thing spray. Anybody want to walk me through what you did? Aaron, what you do? Pi r squared is going to get me the area of the whole circle. And 64 pi, because it'd be 8 squared. Great, 64 pi. You have 70 degrees out of the total 360 degrees, because I only want a portion of that circle. And so we could multiply that out. It is, those zeros would cancel. We take 64 times pi times 7 divided by 36. Anybody get a number for me on that? 39? Am I wrong in saying that? 0.95? Sure. What would my units be there? Meter squared. It's area. Meter squared. Again, just like we did yesterday, you're not finding the full area of a circle, you're finding a portion. So we found a proportion of what we wanted. Yes, ma'am? Absolutely. If we kept it in terms of pi, what'd you get? Yeah, so leave it. If you're going to leave it in terms of pi, leave it as a fraction, but sure. Other questions? Great. Let's look at that unit circle paper I just handed you. So a reminder, next Wednesday, you're going to have a quiz where I'm going to give you, I gave you the quiz 5 days early. It looks like this. This is the quiz. Okay? You're going to have to fill in all of these guys Next Wednesday. It's not hard. Everybody in here will get them all right. If you don't get them all right, you're silly. You'll get them all right. It looks really complicated, okay? But I'm going to explain what they are, and I'll also give you some hints and some clues on how to do it in a little bit quicker fashion, okay? And instead of shoving that all into one day, let's do it right now and work through some stuff. Okay, so today we're only going to work on angles. So we're on the side that says unit circle angles. And we're just talking about angles. So there's a degree line with the degree symbol, and then there's a radians line where we're going to do it in radians. Okay, so this is 0 degrees. If I spin all the way around the circle and go back to the start, how many degrees did I go? 360. So if that's 360, okay, halfway around would be 180. Half of that would be 90. And then you can count by 90s. You can do this however you want, but 90 degrees, 180 degrees. This is 270 degrees down below. Now let's look in this first quadrant. So we know that's 0, that's 90. Does there look like one of those cuts it in half? The middle one cuts it in half. So half of 90 is 45 degrees. Does it look like this line right here cuts 45 in half? It's because it doesn't. Okay? It's as if they skipped a line. Okay, we've got this line, we got that line, but it's like they skipped a spot there. If I put a spot right there, you could see, if I could draw better, that separates that evenly. Now each one is the same distance apart. Okay, and so if you would like, you could make a little hash mark right there and right there. You don't have to. This is just brain thoughts. This is 0, that's 45. If this were to split it up evenly, it's like I split 45 into 1, 2, 3 equal parts. So how much does each one of those lines really mean? 15 degrees. So the one that I didn't mark would be 15. I don't need it. We don't use 15 degrees enough to care about it, so we just skip it. 15. So this one would be 30. This would be 45. This one would be 60. This one would be 75. I don't care about it. So this would be 90. If you had another hash mark there, that would be 105. I don't care about it. This would be 120. Complete the degrees. So if that's 120, then this one is going to be 135. That's 150. That would be 165. I don't care about it. That's 180. This would be 195. Don't care about it. This is 210. This is 225. This is 240. This would be 255. Don't care. 270. 285. 300. 315. 330. That's easy. You already have those memorized. If I gave that to you again right now, you'd be fine. Okay, cool. Let's do radians next. So the other line is radians. Remember, radians are a measurement of an angle. Okay, it's understanding that if I started here at 0, if I were to go all the way around my unit circle and go back to the start, how many radians did I go? 2 pi. That is the circumference of a circle is 2 pi r. We're just not including the radius with it when we're talking about radians. Okay, it's 2 pi. That is the key to today. If you can remember that, you'll be all right. That's 2 pi. So what would 180 degrees be in radians? That is pi. We know that. Okay, if that is 1 pi, what would 90 degrees be? Half a pi. It is pi over 2 because it's half of a full pi. This is 0. This is a half a pi. Pi, oh, that's 2 halves. So 270 degrees would be 3 pi over 2. If 90 degrees is half of a pi, what is 45 degrees going to be? It is pi over 4. And then from there, there's lots of different ways you could do this. Okay, let me look at it this way. 30 degrees, 60 degrees, 90, 120, 150, 180. How many times does 30 go into 180 degrees? 6 times, right? So if a pi is 180 degrees, what is 30 degrees going to be if it goes in 6 times? This is pi over 6. Okay, this is pi over 6. How many times does 60 degrees go into 180 degrees? 3 times. 60, 120, 180. Okay, so this is pi over 3. And let's say your brain is shut down and you're like, oh, I can't do that. You could always just change it, just like we did in Bowen. Okay, it'd be times pi divided by 180, the zeros, boom, 6 over 18, that's pi over 3. Okay, whatever way, you don't need to convert it like that, but we're good. Okay, then we're going to go from there. Notice that on bottom, it goes 6, 4, 3, 2. That's going to be helpful here. 120 degrees, that is 2 pi over 3. Okay, because this is 60. So if I add 60 to that, it'd be 120. That'd be 2/3. This is 3/3. Okay, you could do the same thing with 45 degrees. This is 1/4. So this would be 2/4. So this one right here would be 3/4. You could do it with 30 degrees. Here's 30 degrees. That's 1/6. If I add 30 to that, it'd be 2/6. If I add 30 to that, it'd be 3/6. If I add 30 to that, it'd be 4/6. 30 to that would be 5/6. Notice again, it goes on bottom 6, 4, 3, 2. That pattern is going to repeat on bottom as well. This is 6, this is 4, this is 3, that is 2. This one's 6, this one's 4, that one's 3, that one's 2. It's just going to repeat that pattern because it's 1/6 and 1/4 and 1/2 and all that good stuff. We could spend some time doing the top. I'm just going to write them in. It is 7 pi over 6. It's 1/6 more than a full pi. This is 5 pi over 4. It's 1/4 more than a full pi. This is 4 pi over 3. This one right here is 5 pi over 3 because I'm close to back to 2 pi, but I'm not quite there yet. I'm 1/3 short. Okay. This one, I'm 1/4 short, so it's 7 pi over 4. This one's 1/6 short, so it's 11 pi over 6. There's my setup. You could always convert, but we could just memorize it as well. Again, the keys today, 6432. 6432. Questions with any of those? All right, we'll come back to that. I just wanted to put that in your brain before we went too much further. Let's go to notes. All right. So the key to today is understanding linear speed. Linear speed is what you deal with all the time. That is miles per hour, feet per minute, inches per second, all those different things. Okay? It is whatever your distance traveled is over time. Distance traveled over time. Okay? The issue today is we are dealing with circular motion. So a circle. Okay? So if you look at this first one, to figure out velocity, we are taking s over t. Well, obviously this is velocity. And t stands for time. What does s stand for? Not because velocity and speed are pretty much the same. S stands for arc length. Okay? Because we're working in a circle. So if we're working in a circle, and let's say I went here, and I had a guy running a race, and he started right there, and he ended right there. If I wanted to know how much far he went, I would need to measure that arc length. That would tell me how far he went. Okay? So S is distance. Okay? But here it's S. Remember, S is equal to R times theta. We dealt with that formula yesterday. That told me arc length. Again, don't get overly worked up about formulas, but that's the concept. Everybody okay there? That's different than angular speed. Okay? So linear speed measures how fast that guy is traveling. Angular speed is how quickly is that angle changing. Okay? So how quickly is the angle changing? That's different. Okay? To deal with angular speed, we want to put it with radians over time. Radians over time. All right. So radians is what we're doing today. So if I went to here in 20 seconds, that means I went pi radians over 20 seconds. That's the radians over time. Okay? Omega. I don't know why they used omega, but they did. Okay, that fancy looking W right there is omega. It stands for the angular speed. Okay, this theta, we dealt with it yesterday. My students in 7th period acted like they hadn't seen that before. That's theta. Okay, it means radians. It's an angle measurement, and it's normally radians. So that's radians over time. So whatever my radians is over time. So again, if I went to here, that's pi radians over the time, whatever time it took me. If we want to connect the two, if we want to connect angular and linear velocity, we use this formula where velocity is going to be equal to your radius times your angular speed. Okay? Your angular speed, which is radians over time, which should make sense. Okay? Radians over time. Let's look at this problem over here again. I'm looking for angular speed. Let's say my radius is 3. If I want to know how fast I'm traveling, okay, and I know that I'm going pi over 20 seconds, whatever that is. If I want to know how far he traveled, I would want to know this distance times 3, arc length. S equals R times theta. Okay? If I got my R, it's 3. My theta is pi over 20. Or is it died? It's basically finding the circumference of the circle, but only a portion of it, because I'm doing pi instead of 2 pi. Okay? We're finding the outside. I know it's a little weird. I do the best to explain it, and I feel like every time I get done explaining it, and you guys just stare at me. So we're going to go into some examples and see if it gets any better. But chances are right now, no. The radius of the wheel of a car is 15 inches. If the wheels are traveling at a rate of 3 revolutions per second, how fast is the car moving? Explain your answer in miles per hour. This is what makes this problem yucky. If I didn't do that, this problem would be super easy. Okay? We're going to make it yuckier because we can. What am I trying to find in the end? Am I finding angular speed or am I finding linear speed? Linear. How? How do you know that? Yeah, how fast is the car moving? You don't want to necessarily do that in angles. We want to do that in distance. Okay, so we're trying to find velocity. Okay, we said right here that velocity is equal to your radius times your angular speed. Okay, radius times your angular speed. What is my radius here? My radius is 15. What is my angular speed here? 15 what? But 15 inches, right? 15 inches. What's my angular speed? Sure, let's leave it as 3 revolutions, but yes, you are totally correct. 3 revolutions per 1 second. I had some good answers in the back there. They said we don't really want it in revolutions. We want this in radians. Okay? And so we want to convert from revolutions to radians. So what is the same as 1 revolution? 360 degrees, but we want to be in radians. So what would radians be? 2 pi. Because if I went all the way around 1 revolution, oh, that's 2 pi. And if I just do that right there, I'm in inches per second. I'm in a speed. Okay, my answer is 120 pi. Great. That would be my answer. 120 pi inches per second. The problem with this is that I'm mean to you, and I said, now let's convert this to miles per hour. Okay, so now it's a stoichiometry problem. Okay, just like you would do in your science classes. So, right now I'm in inches and seconds. So let's convert out of inches. If I convert it out of inches, what could I convert inches to? Feet. 12 inches is 1 foot. But that's not what I want. All right, so cool. I got rid of inches, but I want to be in miles. So now what am I going to do? 1 mile is the same as How many feet? You don't have that memorized? 5,280. I don't expect you to memorize that. If I wanted you to do it, I'd tell you 5,280. All right, cool. So now we're not in feet anymore. We are in miles. So we did that conversion. The other conversion I need to do is I'm in seconds and I want to be in hours because miles per hour is just easier to understand. What am I going to do to get rid of seconds? Where's it going to go, on top or bottom? Seconds needs to go on top, and I'm going to convert 60 seconds into 1 minute. And then I want to get rid of minutes, so I'm going 60 minutes is 1 hour. And so if I canceled, my seconds would cancel with seconds, my minutes would cancel with minutes. I'm left with miles per hour. All I have left to do is multiply stuff. So 15 times 3 times 2 pi divided by 12 divided by 5280 times 60 times 60. Take your calculator out, plug and chug. Let's get our answer in miles per hour. We take that whole thing, we plug it in. Show me thumbs up. Is your answer bigger than 16? Thumbs down if your answer is less than 16. Did you include pi with it? No, include pi with it. 15 times 3 times 2 pi. You got a pi button. Don't round it. Use your pi button. Divided by 12. Divided by 5280. Times 60 times 60. I hit enter. I get 16.065 miles per hour. It's weird. The second part was the annoying part. Again, here was the formula we used. Velocity is equal to my radians times my angular speed. Okay? That's what we did. This was my radians. This right here was my angular speed. I just multiplied it by 2 pi. That was what I've taught you today. The rest of it's just annoying unit stuff. Questions on that one? Let's do it again. A remote control car is traveling around a circular track with a radius of 2 meters. If in 20 seconds the car travels 5 meters, what is the linear speed? So again, I've got a circular track. I've got a car. Oh yeah, that's a beautiful car. Okay. The radius of this track is 2 meters. In 20 seconds, it travels 5 meters. So he's traveling around the outside. So I'm going to say to like right there. I don't know if that's 5 meters or not. But right there, the blue outside line here represents an awful job of me tracing. But 5 meters in 20 seconds. Okay? We're doing two things here. We're finding linear speed, and then we're going to find angular speed. We're going to find both here. What is the linear speed? So don't overthink linear speed. We know how to find linear speed all day. What is linear speed going to be? Yeah, it is whatever your distance traveled is over time. Well, they told me directly what my distance traveled was. They didn't make me work for it. It was just 5 meters. So this is 5 meters. Over my time, what's my time going to be? 20 seconds. Cool. 5 over 20, my velocity is 1/4 meter per second. Done. Everybody good on that one? Next thing we're trying to do is find angular speed. Angular speed. We have a formula for angular speed, and we could find it using this, but it's kind of weird. Okay? If we know the velocity, use the other formula instead, because it's going to be easier to understand. Okay? So we know that velocity is equal to my radius times my angular speed. Okay, this is my angular speed, that omega. If I ask you to do this on a test or a quiz, I will give you formulas. I don't expect you to have these memorized, but they're pretty common sense once you get more used to them. What do I know in that formula? Velocity. My velocity is 1/4 meter per second. What else do I know? Radius is 2. Oh, I want to find omega. Guess what I need to do? Divide 1/4 by 2. So it's 1/4 times 1/2. That's what my omega is going to be. It is 1/8 is my omega. Units are a little strange here. What are units going to be? It is radians per second because we are talking about the angular motion. I know it's weird here, but because of what we're doing there, that is the radians per second. Questions on that one? Again, use that simple formula. You'll be good to go. A child is spinning a rock at the end of a 2-foot rope. Someone with 4 kids, this is a bad idea. Don't give a kid a rock on a rope. That's bad things are going to happen. At a rate of 180 revolutions per minute, find the linear speed of when the rock is released. So again, we're using our same formula that we've been using. Velocity is equal to the radius times the angular speed. Velocity is equal to the radius times the angular speed. I'm trying to find velocity. That's my goal. Find the linear speed. What do I know? Radius. What's my radius going to be? 2. It is a 2-foot rope. What is my angular speed going to be? Yep, it's 180 revolutions per 1 minute. The problem with that is we don't want it to be in terms of revolutions. What do I want my angular speed to be in terms of? Radians. So I'm going to change this to 1 revolution on bottom, and on top I want this to be in radians. How many radians is the exact same thing as 1 revolution? It is 2 pi. That would be easy. We can go from there. Does that make sense where we're getting that from? Let's go ahead and, just because I'm a jerk, convert that to miles per hour. Convert that to miles per hour real quick. See how fast that rock is going to knock you out. There we go. We just should have done something like this. So again, know what this is. We converted, the formula we're always using is velocity is equal to my radius times my angular speed. Okay, so we're setting that up. My radius is 2. My angular speed, we got it from that. Aaron? It will not matter yet. Not until we do sine, cosine, and tangent will it matter if we're in radians or degrees. But good question. Okay, we're just typing that in. Thumbs up if you got bigger than, I don't know what the answer is, 40 miles per hour. Thumbs down if it's less than 40 miles per hour. 20 miles per hour. All right, so it's going to hurt. What did we end up getting here? Somebody give me a number. 25.704. I don't want to get hit by that rock, but it doesn't sound, 180 revolutions per minute makes me think it's going faster than that. Still, probably not ideal. Questions on something we did today? All right. Good job. Again, don't let it be more complicated than it